Myself, Ketan Patel from Mahatma Gandhi Institute of Technical Education and Research Center, Navsari, Electrical Engineering Department. My subject name is Testing and Commissioning of Electrical Equipments. Today we discuss about chapter number Installation and Commissioning of Rotating Electrical Machines. Fourth year, 8th semester. Syllabus content: first is site testing and checking, care, services, and maintenance of a motor. Second one is commissioning of synchronous generator, protection and automations of synchronous generator. Third one is synchronous motor, DC generator, and motor with reference to Indian standard and reference Indian standard 4029 2010 guide for testing three-phase induction motors. First one is IS 71321973 guide for testing synchronous machines, IS 93201979 guide for testing of direct current machines. Now, first topic is site testing and checking care services. Now, test conducted after commissioning and before starting the machines. First is visual inspections. Some tests are performed while commissioning. Sometimes the equipment is put into the service after some considerable period after commissioning. The following tests are performed. In visual inspection, in this is ascertained that the connections are tight, surface of the commutator and slip rings are smooth, brushes are in proper positions with correct pressure. In mechanical checks, these checks include nuts on the foundation's bolt, bearing pedestal, alignment of the shaft, and couplings, greases of the bearing. Bearing shaft seat, air gap between the stator and rotor, connections of the terminal, etc. In electrical pre-start test, the tests are performed before the starting the machines. First is measurement of resistance of the winding, measurement of the insulation resistance of the winding, high voltage test, trial start, no load test, on load test, test on cooling system, test on lubricating system, performs tests like starting and running characteristics, reversing, braking, etc. Special tests like vibrations, noise, oscillography for record of starting the current. Next, in temperature rise test. This is a type test. This test is not performed on all the machines but is performed if found necessary. In this test, the rise in temperature is measured after the machine runs at full load for some time and the final temperature is reached and has become constant. This rise final temperature should be within the limit for the class of insulation used. Now, need for test. In this machine, specific type of insulation is used. The insulation can bear temperature up to certain limit. If the temperature developing in the machine is more than that, the winding may be damaged, and after some time it gets shorted and the machine may become useless. So it is necessary to know the rise in temperature in the machines. Temperature rise test of rotating machines. Motor is loaded directly. Load is of mechanical type or DC generator or alternator is coupled to the motor. To the generator, the electrical load is connected. Load is gradually increased and takes up the full load. Readings for the temperature of the winding are taken periodically. Temperature is increasing and reaches to the final temperature and becomes constant. There was wastage of energy when the machine is loaded fully and the temperature rise is measured. So it becomes costly. So the use of this method is limited up to the small capacity machine. More over the large capacity machine, it is difficult to get the load having large capacity. Now, insulation resistance of an electrical installation. Installation resistance of domestic wiring, factory wiring, powerhouses, substations, etc. is measured with the meter or insulation tester. This resistance is measured for two cases. First is insulation resistance between the phases and neutral wires. Second one is insulation resistance between phase and neutral wires with earth. In the first case, whole load is removed from the circuit. All the switches except the main switch are kept closed. Fuse and neutral links are removed. Phase and neutral wires are connected to the maker and the handle of the maker is rotated. Reading of the maker is taken and not. Reading should not be less than 5 mega ohm. If it is then it is this value, it shows there is some fault in the wiring. This fault should be detected and measures are taken to rectify it so that the insulation resistance does not come out to be less than 5 mega ohm. In the second case, phase and neutral wires are connected together and connected to the L terminal of the maker. E terminal of the maker is connected to the earth of the service line. Load, fuse and neutral link are kept connected. All the switches except the main switches are kept on. Handle of the maker is rotated and the reading is taken. It should not be less than the found from the following formula: 50 divided by number of points into mega ohm. The value of the insulation resistance of electrical machine. To measure the insulation resistance of the electrical machine's maker of twice the rated voltage of the machine is used. For 440 volt motors, maker generating 1000 volt is used. Insulation resistance is measured between each phase and body. Value of this resistance should not be less than 2 mega ohm. While measuring the insulation resistance, the temperature is measured. Then the value at specified temperature is calculated and compared with the recommended value. Now, reasons of cause of fault occurring in electrical equipments. We studied causes of fault occurring in the electrical equipment by dividing them in four types. Now let us think how this can occur. For example, one case in the category of mechanical faults in the improper bearing. We also saw the effect of this fault on the performance of the machine, but it is necessary to study the causes of bearing become improper. Now we shall study the reason of occurring mechanical and electrical faults. Causes of occurring mechanical fault. First is causes of improper bearing. May be long use of the bearing, defective fitting of bearing during maintenance, improper lubrications, using wrong grade of grease, feeling less quality of the grease. Second one is causes of broken brush holder include use for long period, improper fitting during maintenance, more or less pressure of the spring on brushes, use of the wrong grade of the brushes, wrong angle of brushes. Causes of loosening of computer bar include excessive vibrations, loosening of the mica ring, overload for long durations, etc. Causes of loosening of the armature core include unbalancing of magnetic force, overheating of the core. Fifth is causes of bending of shaft included excessive length of the shaft, more overhang, misalignment, carelessness during opening and fitting the equipment. Now, causes of electrical faults. Causes of puncturing in insulation include prolonged overvoltage, overheating, cut or scratch in winding, shaft bearing or in winding, aging of winding, etc. Causes of short circuit in winding include worn out insulations, overloading, carelessness during maintenance. Causes of loose connections include excessive vibrations, not using the spring washer, insufficient force while connections. Causes of damaged commutator include formations of pits on the surface of the commutator, loosening of connections with the risers, wrong angle of brushes, improper pressure of brush, and heavy sparking. Causes of wrong setting of brushes included carelessness of fitting of brushes while maintenance. Wrong electrical connections include carelessness during maintenance, over confidence, insufficient knowledge, use of wrong symbols to the wiring diagram, worm out, breaking of ferrules. Now, cases of magnetic faults. Causes of shorting of armature core include excessive vibrations over magnetization, use of improper tools during maintenance, carelessness, etc. Causes of improper fitting of poles with the frame or yoke included improper fitting of poles, so avoiding washer while fitting lace pressure and excessive vibrations. Now, probable fault in induction motor due to poor maintenance. In induction motor is the rotating machines, its proper maintenance is necessary. First is connections of the terminals and earth become loose due to the vibrations. Sparking may be the result. The terminal may get burnt and motor can catch fire. If the connections are not made tight periodically, earth resistance increases if the earth connections gets loose. Temperature of the bearing increases, noise is produced and quantity of lubricant required increases if maintenance of bearings is not done properly. If proper care is not taken about the belt and if the belt becomes too tight, the load on motor increases, motor gets heated up. On the other hand, if the belt becomes loose, the belt slips and improper transmission of power result. Heat dissipation from the winding reduces and its temperature increase if the dust dirt are not removed periodically from the winding. Insulation resistance of the winding resistance. There is a probability of the earth fault if the varnishing of the winding is not done as the required time. Grooves are produced on the slip ring and sparking occur if proper maintenance of slip rings and brushes is not done. If proper maintenance of the concept to the starter and control gear is not carried out, the contacts get spoiled. Single phasing may result if one contact does not work properly. There is a possibility of burning of the winding. Magnetic unbalance is produced and vibrations produced if the air gap between the stator and rotor is not properly maintained. Motor draw instead current if the rotor rubs with the stator while rotating. So there is a possibility of accidents if the nuts and bolts on foundation are not tightened properly. So these are all the matter are sighting testing, checking and care and services. Now, maintenance schedule of the induction motor, synchronous motor, likewise. Like other equipments, is proper maintenance of induction motor is done, it can give services for long period without giving trouble. So here the samples checks on AC motor and frequency of the inspection is like a weekly, monthly, 6 month, etc. In weekly basis, temperature, IB bearings, temperature center motor, vibration pen at pin state spot, check cleanliness of motor, look at conditions of junction box and cable, visually look for water on motor, check fan with stroboscope, listen for unusual noise. Monthly wise, measures amperes, vibration analysis with analyzers, different 10 pen above. In 6 months, carefully check the base, steel and foundations concrete. In in this AC motors, daily, weekly, monthly, half yearly or yearly wise basis also we can check the all the parameters. In daily basis, connections of terminals and earth. Check the connections of the motor leads and earthing and its conditions is required to tighten if found loose. Winding of the motor. Check with the whether the winding gets hot. Reduce the load if the found overheated. If control equipments, inspect starter, speed controls and repair if defect is found. Oil ring lubrications. Check with the oil ring is working in oil ring lubricate water. Measure the temperature of bearings. Check and play and add oil if found necessary. Okay. Then weekly other points is belt tensions, inspection of air gap, cleaning of windings, context of starter, oil in ring bearings. Okay. Now yearly wise points is high speed bearings, windings, motor, switch and fuse, starter oil, insulation resistance, air gap, and overload and breakers. Now, commissioning of synchronous generator protections and automations of synchronous generator. In this case is the number of tests included in this theory. First is measurement of DC resistance of armature and field windings. Dielectric test on armature and field windings, mechanical balancing test, temperature rise test, overspeed test, harmonic analysis, telephone interference, short circuit test, reactance and time constant, speed torque characteristic, efficiently calculations, bearing by insulation test, direction of rotations, current balance on no load, and commissioning test. Now, testing synchronous generators. In commissioning test, first one is insulation resistance test, measurement of DC resistance of armature and field windings, waveform interference test, line charging capacity. In performance test, sleep test, short and short circuit test, determinations of transient and subtransient parameters, determinations of sequential impedance, separations of losses, temperature rise test and retardation test. Now, symptoms and causes of motor troubles and how to remedy them. Now, trouble symptoms like are determined by inspections. Okay, when motor will not start its load, no value voltage at the motor terminals, low line voltage, fuse is blown, poor contacts or connections, press not sets up properly, motor connected to the wrong power circuits, motor terminals not proper connected to the power circuit, service lines or transformer or both too small, motor overloaded, shorted, grounded or open windings, worn bearings along the rotating part to drop down the stationary belt. Okay. If these problems occur, the test remedy are see if lights on the same circuit burn or connect test lamp across motor terminals with the motor switch closed. Check voltages if abnormal voltage drop in service lines. Rewire circuit with larger wire. Check size and conditions of fuses. Examine and tighten all the loose connections. See that the brushes seal well on the commutator and are free to move in their holders. Check the brush settings. Check nameplate data. Check motor line connections. Check transformer. Check speed. At overload usually causes the speed to drop below nameplate marking. See the J and K and inspect bearings for tighten and lubrications. Motor seems to weak or run slow. It determined by inspection. If low voltage at the motor terminals, if motor overloaded, poor contacts or connections, motor connected to the wrong power circuits, motor improperly connected to the circuit, motor winding damage, then the test and the remedy are remove load if motor operates at rated speed, check bearings for tightness and lubrications, check all contacts at main switches, or auxiliary switches used to operate motor. Clean commutator and make sure that the brushes are free in holders. Now, motor runs too fast. Check speed. High voltage, motor control to wrong circuit, motor terminals improperly connected to the circuit, frequency too high, motor windings damaged, and the remedies is check voltage on line, determine frequency stamped on motor nameplate and check with the power source. If DC motor, test for open shunt field circuits. Now, motor runs too hot. Determine the thermometer readings. Symptoms is distinct order of burning insulations. The motor overloaded during the starting running period, line voltage too high, line voltage too low, belt too tight or coupling or gear out of line. Insufficient lubrications, faulty combinations, motor windings damaged, one fuse blown into two or three phase motor, circuit allowing motor to operate one phases. Remove load, run motor ideally, give it a general inspections. Apply load gradually and not characteristic. Then adjust bolt, gear or coupling. If trouble is not, eliminate check findings for defects. Where motor runs, motor fuses blow. Then determine by inspection symptoms, motor is stop, motor gets hot and motor refuse the start. Then motor overloaded fuse too small, motor connected to the wrong power circuit, motor improperly connected to the circuit and damage motor windings. Its remedies is check fuse informations sent with the motor. Now the problem symptoms is excessive flashings, blackened commutator and brushes wear rapidly. The problem cause protruding mica or rough commutator, dirt or oil on commutator, brushes stuck in holders, wrong brush positions, weak springs, overload, motor windings damaged. Remove armature and have a thin cut taken off the commutator with sharp lathe cool. Clean commutator with a soft rug. Make sure brushes ride easily in their holders and replace springs. Now, excessive brush wear. Determined by inspection, one set of the brushes should function statistically for at least 2500 running hours. In excessive sparking of flushings of the brushes, wrong quality brushes, rough commutator or high mica between the commutator bars and overload, then the remedies are inspect conditions of commutator, also brush spring tension. Replace brushes to ensure proper commutations. If mica elements produce, take a thin lath cut from commutator. Polish with number of sandpaper, use no foil. So these are the all the troubles and its causes and its remedies. In troubleshooting of AC motor, motor will not start, supply or started keeps out of start, motor start but has no torque, motor does not reach full speed or take a long time to accelerate, motor overheating, no load amperes and excessive full load amperes, mechanical noise or vibration noisy, vibration bearings overheatings, motor amperes in excess of nameplate full load ampere on load, excessive noise, unbalanced amperes in different phases when motor loaded and motor runs in wrong direction. So these are the troubles and we are we then find the faults and repair the problems. In slip ring motor, synchronous motor, DC motor, DC generator, all are first find out the troubles and its causes, and then remedies. First, uh, in slip ring induction motor, runs slow, runs hot, fails to start. In induction, squirrel cage induction motor runs hot, runs slow, fails to start. The causes is overload, low voltage, low frequency, one phase open status slot, overload, blown fuses, bearing jam, brush do not touch, collector rings, open in rheostat. Okay, so these are the all the troubles and its causes. In synchronous motor and synchronous generators, the troubles are motor fail to start, motor trips the circuit breaker, motor does not have proper speed, motor is hunting, starter not working, stator overload in spots, field overload. So these are the troubles. And causes is wrong connections, motor frictions, low voltage, exciter, circuit open, field short circuited, motor may be overloaded, field may be overexcited, fluctuating load on the motor, open circuit phase, rotor not centered, open phase, unbalanced currents. So there are the number of causes occur in the synchronous motor. Then remedies are we check the connections, then check alignment, reduce impedance of the external circuit, test with measure for continuity, test the priority, reduce load, examine the field, adjacent field current, check and correct it. Okay. Now troubleshooting of DC motor and DC generator. The troubles are motor will not start and its causes is blown fuse, shaft jam, shunt field open armature circuit, presses are not making contact with commutator, bearing is sized, current is not available. Okay. Then remedies are test the fuses with ohmmeter with circuit load, checking the bearings and its lubrications, locate the defect in shunt field circuits, inspect the commutator for partial hunting, adjust the springs in case brushes are worn out, replace them, replace the repair of the bearing, check starter. While uh, the DC motors starting slow running period, then because this is armature bar short, low voltage, overload, brushes not in neutral positions, excessive starting resistance in circuit. Then remedies is get the motor repair shop, check load current and supply voltage, check load current and hunt heating, check normal positions, check correctly, set starting handle in full start positions. Now, other is motor runs fast. Motor start but has no torque. Motor does not reach full speed or takes long time to accelerate it. Motor overheating, sparking at the brushes. Motor ampere access on nameplate full load, ampere on load. Motor does not slow down due to increase in load. Field winding get hot, etc. are the causes troubles. Same way in DC generators, the troubles are overheating, number of voltage, low voltage, high voltage, fluctuation voltage, sparking brushes, etc. are in generators. Now, checking of the electric motors. When motor fail, it is often difficulty to see why it is failed just by looking at it. A motor plant in storage may or may not working regardless of its physical appearance. A quick checkout can be done with a simple ohm meter, but there is a lot more information to collect before actually putting it to use. At no time during the motor check out is power required if it is connected, distance if before, at emptying the steps below. First is check the outside of the motor, check the nameplate on the motor, checking the bearings, checking the windings, troubleshooting other potential problems like check the start of run capacitor used for starting or running some motors. Check the rotor bell housings of the motor. Check the fan. Choose of the right motor for the conditions in which it will be run. Now, commissioning of synchronous machines. These single isolated machines as a generators for starting alternator and put line on bus bars. They are the commissioning of synchronous machines. Okay, thank you.